We are starting a new unit today, and we're going to be talking about a new function, and it is called an exponential function. And so today our goal is to learn how to graph these new exponential functions. But before we jump right into graphing, we need to learn some basics. So what is an exponential function? It is a function of the form y equals b to the power of x, where b is not allowed to be 0. Okay, if you've noticed, the biggest change from our old equations to this new one is that x is now up in the exponent, which is also why it's referred to as an exponential function. So some important vocab. This b right here is referred to as the base of the function. And as I wrote here, x will always be in the exponent. Okay, you will never see x big anymore. It's a little guy, it's up in the exponent. And so our goal today, like I said, is to graph these. So to get us started, we want to see what kind of the basic graphs look like. There are going to be two types of basic pictures that we're going to be working with today. The first one, we're going to be using the equation y equals 2 to the power of x. And so we're going to graph this the old-fashioned way. We're going to make an xy table. As you can see, I've already chosen 7 x values for us. So we're simply going to take each one of these 7 x values and put it right here in our equation. So the first problem, we're going to put -3 where x is. So it would look like 2 to the power of -3. And if you're typing that in the calculator, the power button, don't forget, on all of these, it's 2. You're using your power button, and then whatever the number is up in the exponent. So type in your calculators 2 to the power of -3. And you should get a decimal, and yes, a decimal is okay, 0.125. So we're going to repeat the exact same thing with the -2. So 2 to the power of -2. And again, you're going to type that in your calculator. Yes, you're going to get a decimal again, and you should get 0.25. So do me a favor, take a moment, finish filling in this table real quick, and then we'll make sure you got your answers right. Okay, so let's see how you did. If you finished up 2 to the power of -1, you should have gotten 0.5. 2 to the power of 0, you should have gotten 1. 2 to the power of 1, you should have gotten 2. 2 to the power of 2, you should have gotten 4. And 2 to the power of 3, you should have gotten 8. So there are your 7 pairs that we are now going to graph. So let's talk about how to graph some of these decimals. -3 is to the left, 0.125 is up. Well, I know how to go left 3. 0.125 is a very, very small number. So we're talking about going up just a little bit on the graph. Now we're going to do this one. Left 2, up 0.25. So left 2, we're going to go up a little more than we went before. Not a whole bunch more, but a little more. Then we have left 1, up 0.5. So left 1, and now we're at like the halfway point of the box. We don't move left and right at all. We only go up 1. So straight up 1. Right 1, up 2. Right 1, up 2. Right 2, up 4. Right 2, up 4. And finally, right 3, up 8. Right 1, 2, 3, up 2, 3, 4, 5, 6, 7, up 8. Now, if you notice, this is a graph that kind of is slow to start, but then goes up really fast. This is what's referred to as an exponential growth function. So what does this look like when we connect it? Well, let's go ahead and connect the dots that we have. So we have dots that go like that, and they slowly, quickly go up this way. Now, what else happens other than just those few dots? Well, this side keeps going up super fast. If we added more rows to this table, those numbers would start getting very large very quick. Now, the other side's a little different. Okay, the other side, if we kept adding numbers this way in the table, most people wonder, well, what happens here? Does it eventually go down below the x-axis? Does it eventually touch the x-axis? And the question to both of those is no. Even if we kept going this way, these decimals would just keep getting smaller and smaller and smaller. This graph is never, ever going to touch the x-axis. So we're just going to, from here, we're just going to go that way with an arrow. Notice I'm right above the x-axis. Don't cross it, don't touch it, don't go below it. I'm right on top of it. Now there's some more important information that we need to know about this graph. So below your graph, I want you to jot down some things. Here is the stuff that you need to jot down. So all of this relates to these being called exponential growth. Growth is an important piece of the puzzle here. Growth means that something is going up. Well, this one, because it's going up, it will always rise from left to right. If you notice, this graph slowly goes up, slowly, 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 then it shoots up real fast. The base to be growth must be bigger than 1. Doesn't matter what it is. Now, this base here was 2, but it could be 3 or 4 or 5. It can be any number we want. Now, this was that other piece that we were just talking about. These graphs never touch the x-axis, ever. They go this way forever, but they never touch. There is a fancy name for that, and you do need to be familiar with that name. It is called, and this is the word, it's called an asymptote. Again, that's pronounced asymptote. So the asymptote right now for this graph, okay, and you can add this to your notes, the asymptote is the x-axis. So right now, this graph, the asymptote, in other words, the imaginary line that never gets touched, is the x-axis. So this is one type of picture that you're going to see today. It's growth. It will consistently go up every time. Now, we're going to look at a new function. Our new function is called an exponential decay function, and this is the equation that we are going to be graphing. So we're going to start this one the exact same way that we just started the other one. We're going to make our little table of values. So let's look at this first number. Same 7 numbers. When you plug it in, though, I want to make sure you know how to use the calculator properly. Notice I am writing it in parentheses 1/2 to the power of -3. That is an absolute must in your calculator. Parentheses 1 divided by 2 to the power of, and then whatever number is in the exponent. Yes, you must use parentheses. No, I don't want you to use decimals in the parentheses because you're not always going to have a nice decimal. So type this in again, parentheses 1 divided by 2 close parentheses to the power of -3. You should not get a decimal this time. You should get a whole number, and that whole number is 8. So let's do the next one. Parentheses 1 divided by 2 to the power of -2. You should get a 4. So go ahead, pause and finish your table, and then we'll see how you did. Okay, so let's see what answers you got. When you did 1/2 to the power of -1, you should have gotten 2. When you did 1/2 to the power of 0, you should have gotten 1. 1/2 to the power of 1, you should have gotten 0.5. 1/2 to the power of 2, you should have gotten 0.25. And finally, 1/2 to the power of 3, you should have gotten 0.125. Do you notice anything about the two tables that we just made? You should notice that the numbers are just in the reversed order. And that's because 2 and 1/2 are related. So let's take a look what this graph is going to look like. Left 3, up 8. 1, 2, 3 to the left, up, all the way to 8. Left 2, up 4. Left 2, up 1, 2, 3, 4. Left 1, up 2. There we go. I don't go left and right at all, but I go up 1. So I'm right here. Right 1, up half a box. So right 1, half a box. Right 2, up 0.25, so I'm a little less than where I was. And finally, right 3, up 0.125. This is where we make that little bitty jump. 1, 2, 3, up just a little bit. So it should look a lot like the graph we just did, only flip the other way. So if we connect the dots that we know we have this much. And so if you think about what we just did, this side of the graph is going to shoot up, and this side's going to do exactly what the last one did. It's going to keep going this way a little at a time, but it's never going to touch the x-axis. So let's take a look at some of the very important information that we need to know about these particular graphs. These exponential decay functions. Here's some important information that you need to add to your notes. Most of this should make very much sense. Because they are decaying, when we think of the word decay, we think of things going down. And that's exactly what this says. It falls from left to right. It goes down very, very quick, and then it turns and it starts to slow down. But it does go down or falls from left to right. These, the base, okay, that's again this part right here, the base must be between 0 and 1. So if you think of numbers between 0 and 1, we're talking about fractions or decimals. And yes, some of them will be fractions, some of them will be decimals. These do the exact same thing the other ones did. It never ever touches the x-axis. So that x-axis, again, we call it an asymptote. X-axis is the asymptote. So this is the other type of main graph that we are going to be working with today. So you're either going to have a growth equation that goes up from left to right, or a decay function that goes down from left to right. And so we're now going to look at some important rules that we need to add to our notes. So turn the page. Along with the basic graphs that we just looked at, we're going to have some shifting rules. And these are the exact same shifting rules that we've seen with every single kind of graph we've made. Okay, if you notice I have two boxes here. They're each pointing to a specific letter. This first box is pointing to the letter C. So C is up in the exponent attached to the x. And so the information you need to know is that this moves the graph to the left or to the right. The exact same rules we've heard before. If it is a positive C, it moves it to the left. If it's a negative C, it moves it to the right. So the other one that it's being pointed to is D. Now notice D is large. It's not up in the exponent. It's down in the bottom. It's a bigger number. And so D moves the graph up or down. If it's positive, it goes up. Whoops, that should be a positive D. It goes up, and a negative D goes down. So go ahead and finish writing those down, and then we'll talk about how to put it all together. So we're going to look at a 3-step process that you're going to go through in order to graph these. So when you are graphing these exponential functions, you're going to be making a table. So you're going to use what I refer to as the base equation. The base equation looks like this. Okay? There may or may not be an extra number here, but the base equation ends with x. And you're going to fill in that table with 3 specific x values every time. Those 3 x values are always -1, 0, and 1. And you're going to graph those 3 points. If the 3 points go up, it's going to be growth. If the 3 points go down, it's going to be decay. Once you've made your original 3 points, then you shift the 3 points in the appropriate directions. That's using the rules you just wrote down in those boxes. The left and right, and the up and down. Now last step is very important. If the graph shifts up or down, the asymptote must also shift up or down. Okay, the asymptote, that imaginary line that we cannot touch, it moves. But it only moves when the graph is shifted up or down. So whenever that happens, we show it on the graph as a dashed line. And again, when we get to examples, we'll show you what all of this means. And so we're going to go ahead and take a look at our first problem. So you are being asked to graph y equals 2 times 3 to the power of x minus 2 plus 1. So the first thing you want to identify is your base equation. Your base equation ends with x. So y equals 2 times 3 to the x. As soon as you say x, the base equation is done. Once you know what your base equation is, you're ready to fill in your table. So we're going to put this -1, 0, and 1 where the x is. So this one's going to look like 2 times 3 to the power of -1. And that's exactly how you're going to type it in your calculator. 2 times 3 to the power of, that's your exponent button, -1. And yes, you'll get a decimal, and yes, it's okay to round. This decimal should round to 0.67. We're going to do the same thing with 0. 2 times 3 to the power of 0. Your calculator, go ahead and type that in. You should get the number 2. Finally, if we type in a 1, 2 times 3 to the power of 1, yes, your calculator should give you a 6. So these are your 3 base points. So as it says in the directions, use the equation to fill in a table, then graph those points. So now we're going to graph them. So I'm going to go left 1 and up 0.67. It's a little more than half. So left 1 and up a little more than half. Stay at 0. Go up 2. 1, 2. Move to the right 1 and go up 6. Right 1, 1, 2, 3, 4, 5, up 6. So as you can quickly see with these 3 dots, this equation is a growth equation. So we're going to connect them, and we're going to go all the way and keep going up with your arrow. And then we're going to go this way and keep going to the left. Remember, don't touch the x-axis. So that's the first step. Second step, we're going to shift. So we have 2 numbers here. We have a -2 and a +1. So the minus 2, if we look back at our rules, up here, a minus 2 would make it go right 2. So it makes right 2. And a plus 1 here, plus D makes it go up 1. So we're going to go up 1. So now you're going to take your 3 dots that you just made and move each one of them to the right 2 and up 1. So I'm going to start by putting my pencil here. I'm going to count 1, 2 to the right, 1, up. Come here. 1, 2 to the right, up, 1. Go to the third dot. 1, 2 to the right, up, 1. Now, do not connect them yet. The reason is we need to shift your asymptote. So it's your up or down amount. So we went up 1. Well, the asymptote was here at the x-axis. So if it goes up 1, it's now right here. And so we're going to put a dashed line. I'm going to use a different color so you can see it. I'm going to put a dashed line right there through the number 1. That is now your new line that you cannot touch. And so I'm still going to connect my dots and go up. And I'm going to connect and I'm going to just go left, 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 and never touch. So all I did was I shifted my asymptote along with my graph. And that is all there really is to graphing. If you can make the parent points and you can shift, you're good to go. So let's take a look at another one together. So the first thing we want to establish is our parent equation. I'm sorry, we called it our base equation. Let me make sure I use the right word. Our base equation ends with x. Y equals 1/2 times 4 to the power of x. Stops right there. So let's plug in our 3 numbers. 1, you're going to type in your calculator, 1 divided by 2 times, whoops, that should be a 4. 1 divided by 2 times 4 to the power of -1. 1 divided by 2 times 4 to the power of -1. Your calculator should tell you 0.125. Then we're going to do 1 divided by 2 times 4 to the 0. You type that in, your calculator should tell you 0.5. Then we're going to type in 1 divided by 2 times 4 to the power of 1. Your calculator on that one should tell you 2. So let's go ahead and plot our points. To the left, 1, up 0.125. That's that little bit again. Left 1, up a little bit. Don't go left and right. Just go up a half a box. So up a half a box. Right 1, up 2. Right 1, up 2. So again, look at what direction your points are going. Your points are going up. So we're going to connect them and we're going to go up and keep going with your arrow. And then we're going to go left and just keep going forever and ever. So that is your original graph. Now we have to shift. So we got 2 numbers. We have a +1 and a -3. So +1, a plus C, if you look back at your rules, means that we're going to go left 1, and a -3 means we are going to go down 3. So each point, put your pencil at the first one. Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. Notice I'm staying like in the partial boxes. Left 1, down 1, 2, 3. So there's my 3 new points. Now we have to draw in our asymptote though. Which amount was the up or down? Well, it's right here. We went down 3. So from the x-axis, I'm going to go down 1, 2, 3, and I'm going to draw my dashed line right there. That's your imaginary line that you can no longer touch. So go back to blue, connect the 3 dots, and keep going up. And then go to the left, and don't ever stop. So hopefully you're looking at these thinking, oh, this isn't too bad. So we're going to have you pause the video, and we're going to have you try number 3 completely on your own. So let's see how you did with this one. First of all, your base equation should have been y equals 3 parentheses 0.25 to the power of x. And so you should have typed in 3 parentheses, whoops. In your calculator, you should have done 3 parentheses 0.25 to the power of -1. Your calculator should have told you the number 12. When you did it with 0, you should have gotten 3. When you did it with 1, you should have gotten 0.75. So if we graph these dots, we're going to go left 1, up 12. Left 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make 2 fake boxes, 11, 12. I don't go anywhere. I just go up 3. 1, 2, 3. And then I go right 1 and up to 0.75. So right 1, I go up past the halfway mark up to 0.75. So which direction are these points going? Well, you should have said, oh, they're going down. So you should have connected them and gone down and started to curve. And then what happens here? We curve and we just go slowly on down. Remember, don't touch your x-axis. We curve and we keep going slowly down. The next thing you should have done was talked about your shifting. 2 numbers, +1 and -2. This +1, you should have gone to the left 1. And this -2, you should have gone down 2. So I'm going to take my pencil, I'm going to go left 1, and I'm going to go down 2. Here I'm going to go left 1 and down 2. Here I'm going to go left 1 and down 2. So hopefully you shifted those correctly. And then the final thing that you needed to do was make your asymptote. The asymptote also goes down 2. So 1, 2 down. Make my dashed line. And then go ahead and draw in. Down, 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 down real quick. Then we hit it and we curve and we go really, really slow. So go down fast, then slow down. So we're going to try one more together because this one looks a little different. So again, let's start with our base equation. And that should be y equals -4 parentheses 1/2 parentheses to the power of x. So in your calculator, -4 parentheses 1 divided by 2 close parentheses exponent -1. If you type that incorrectly, you should get -8. Same thing here, -4 parentheses 1 divided by 2 close parentheses to the power of 0. You should get -4. Finally, -4 parentheses 1/2 to the power of 1, and your calculator should tell you -2. So let's take a look at what this is going to look like on paper. I'm going to go left 1, down 8. Left 1, 1, 2, 3, 4, 5, 6, 7, down 8. I'm going to go nowhere left and right, down 4. 1, 2, 3, 4. Right 1, down 2. Right 1, down 2. So this graph is totally different than the rest of them. It's because it's flipped over. So here's what's important. Yes, we still connect the 3 dots. Yes, we keep going down from there. Yes, we're going to curve. Don't touch the x-axis. So all that's going to happen is we're going to curve, but this time we're going to stay under the x-axis instead of above. We're going to stay under it instead of above. So if you ever have a negative here in the front, your whole graph is going to start out down. So now we got our shifting. 2 numbers. We got a -2 and a +3. So what does this -2 do? Since it's a negative, it goes right 2. The +3 makes it go up 3. So start here at my first dot. Right 2, up 3. Second dot, right 2, up 3. Third dot, right 2, up 3. Now, we also need to put an asymptote in there. That would be you're up 3. So 1, 2, 3 up. Make a nice little dashed line. And so remember, connect your dots. Keep going this way to the left. Keep going this way down. All right, so we have one more little thing to talk about. This is a very, very important base in math. It's called the natural base. So jot down this little definition. This is a base that is represented as the letter E, but it has a constant value. So the best comparison I can make, this is similar to the letter, or to pi. We all know that pi really is just a number. E is the same way. And so E, the way you find it, the buttons that you press, if you're looking at your calculator, you're looking for a button that looks like this. LN. If you actually look above that button, you'll see a little E. Okay, so if you want to see what I'm talking about, I'm at my calculator. Oops, let me get rid of all that stuff. So if you're talking about the button, if you guys see right here, that's the LN button I was talking to you about. If you look right above it, you see e to the power of x. So the way we would get it, since it's above it, you would press second and then the LN button. So if you see what I'm talking about, second LN. And there's your e. And it's waiting for you to put in an exponent. So we're just going to try a couple in the calculator. E to the power of 1. So let's go ahead and put a 1 there. When we hit enter, it's a decimal that does go on and on forever. So we can go ahead and round it, and I'm okay with you rounding to 4 decimals. So 2.718.3. 2.718.3. So let's try this one. Second ln, there's your e, to the power of 8. So we get a big number, 2,980.95. So we'll do 2,980 point, what was that, 95? So this one, it's just 3,000, then the e. So 3,000, second ln, there's your e, and that exponent was 0.2. And so we get 3,664 3,364.21. 3,364. No, I wrote that wrong. Sorry. 3,000. What was that number? 3664. 3664.21. So the reason that I wanted to introduce this is because you can graph with these as well. So we're going to do the exact same steps we were just doing, but we're going to be using the E button the whole time. So exact same steps, start with our base equation. Our base equation would be y equals 2e to the power of x. So the same button you were just using in the calculator. 2e to the power of -1. Yes, you can round. Your calculator should tell you 0.74. Okay, try this one. 2e to the power of 0. You type it in correctly, your calculator should tell you 2. And finally, 2e to the power of 1. Your calculator, when you round it, should tell you 5.44. So let's go ahead and graph these the exact same way. Left 1, up a little past the halfway point. Left 1, up a little past half. I don't go left and right. I go up 2. And I go right 1 and up 5.44. Right 1, up 1, 2, 3, 4, 5.44. And so we need to connect these the same way we connected the other graphs. So if you notice, these three are going up. So this is growth. So I'm going to go up, 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 keep going up. And yes, it still has an asymptote. So I'm going to go to the left, to the left, to the left, to the left. Don't touch the x-axis. Next thing we talked about on the other problems was the shifting. So I have two numbers. I have +4 and -3. +4, we should know, makes the graph go left 4. -3 makes the graph go down 3. So starting here, left 1, 2, 3, 4, down 1, 2, 3. From here, left 1, 2, 3, 4, down 1, 2, 3. And here, left 1, 2, 3, 4, down 1, 2, 3. So there's your shifting. Yes, we have an asymptote. So if this is down 3, our asymptote's going to go 1, 2, 3 down. The dashed line right there. And you guys are going to go up, up, up that way. And then left, left, left that way. So go ahead, pause the video, try this one completely on your own. All right, so let's see how you did on your very last problem. So your base equation is y equals -1 e to the power of x. So you should have typed in -1 e to the power of -1. So your first number your calculator should have given you was -0.37. -1 e to the power of 0. Calculator should have told you was -1. And -1 e to the power of 1. Calculator should have told you was -2.72. So let's take a look at what these points look like. Left 1, down not quite halfway. So left 1 not quite to the halfway point. No left and right, but go down 1. Right 1, down 2.72. Right 1, 2, now we're a little over the halfway point, 0.72. So notice all three dots are below the x-axis. That means we're going to be completely below the x-axis, just like example 4. So connect them in the direction they're going, and go down, 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 down like the dots are going. This is the side that goes left, 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 and never touches. Completely below. Let's see how you did on your shifting. You had two numbers. This first one, minus 3, should have made you go right 3. This plus 5 should have made you go up 5. So the asymptote, oh, no, we're not ready for that. So from this first dot, right 3, up 1, 2, 3, 4, 5. Right 3, up 1, 2, 3, 4, 5 from the second dot. And from the third dot, right 3, up 1, 2, 3, 4, 5. Now we're ready for the asymptote. The asymptote should be up at 5. So 1, 2, 3, 4, way up here at 5. And so connect and go down, 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 down. And connect and go left, 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 left. And that's the end of the lesson.